Okay, here's my exam 3 corrections. Starting off, I changed the sign to negative. I added in density and sine theta because of SOHCAHTOA. I think it would be sine, and I forgot density in the original. I think it would be negative. My logic in that was the way you bring it over, right? In the Navier-Stokes, when you're solving a velocity profile. I guess this could be negative too, but it depends on how you define the delta p. So I had left that. That's kind of what I was thinking there. Then I changed this to viscous because it would need to be viscous for this to work. We would want constant viscosity. Then I don't know why I didn't do these on the original exam. I think it could be either because t doesn't really show up in any equation. I guess it could affect viscosity, but if we have constant viscosity, then it can be either. And that needs to be laminar because we need that for Navier-Stokes. I don't think we can tell here because if it's 30 degrees, the picture will look like this. But the pressure could potentially be P1 could potentially be less than P2, but we have gravity involved here, so I don't think we can tell here. And from the other way, if it's flowing upward, it would have to be overcoming gravity, so P2 has to be greater than P1. So that was my thinking there. I got this right. Here, I had a negative delta G, which canceled out over here, and I just didn't worry about that this time. And I specified this as being fully developed. It's because there's no change in the theta direction. So those my two changes here, and then for the most part, this was the exact same equation. I got the boundary conditions right. Here I had this slight problem in my momentum balance, and I also forgot the plus c when I integrated, so I included that here this time around. I solved for my boundary conditions. I got this equation, which I think is the correct one. Here, I wasn't too sure about this. I think the only glaring mistake I noticed was this negative sign, which I think is bad algebra from this part. Otherwise, I don't know. This could still be wrong, but this is what I changed. I got this part right, and then here, I think it's fairly close. For whatever reason, I integrated instead of deriving. I don't know why I did that. But here I just derived, and the process is the exact same. I just derived instead of integrating. And I arrived at this solution instead. And that was the whole exam. Yeah, thank you for a good semester. Thank you.